So we can title this at the top of the next page. This is going to be our method for graphing both sine and cos. And so I'm going to use the capital letters A, B, C, and D to represent vertical stretches, horizontal stretches and compressions, horizontal translations, and vertical translations. And this works for both sine and cos, and the letters and notice this is in factored form. The B value has been factored out. So there's a nice little acronym that we're going to use to remember this special order that we're going to graph it in. And it looks like this. So our method for graphing, I call it DAB-C. It's got the dab in it. I know it's awesome already. Okay. So the DAB-C, if we look at the letter order, it goes against the normal order that we do, moving from left to right. But this order is based on some of the characteristics that we noticed when we were graphing things separately. So when starting with the D value, that D value changes things up and down. This, well, maybe I'll use the word draw instead of graph. We'll draw your center line. The first thing you're going to do is your D value is always your center line, your average, your sinusoidal axis. So you're going to start with that. Once you have your center line, what did the A tell us in the graph? The amplitude. So you can use the amplitude, which is how far something is from the center line, to find the maximum and minimum. What does the B value help us find? Right. So every time we've done a graph so far, we found the period, and then we divided it into 4 different parts. So we're going to find the period, and remember that our formula for the period is always 2 pi over the B value. So we're going to find the period and divide it into 4 equal parts. So you know how we had 2 pi? We cut it in half, we wrote pi. Cut that in half again, pi over 2. So we had 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are those 4 equal sections that we made. Okay? Now the dash is here because at this dash, maybe I'll space it out even more. At this dash, you temporarily before we do the phase shift or the translation left and right, we temporarily graph with a dotted line. And then finally, we take that temporary graph and we apply the horizontal translation. So we write these steps down, and now we're going to use these steps to see what this looks like. Yes? The vertical translation was done already, very first thing when you drew your center line. Okay? So this only works with sine and cosine because of a number of the characteristics of sine and cosine to begin with. Okay? So here is our first example. You have space at the bottom of page 531 to do an example or two. We're going to do 2 examples. So here is our example 1. We are going to graph y equals 3 sine 2 x plus pi over 4 minus 2. So when you go to graph these, the first thing you're going to think about is your center line and your amplitude, just to sort of figure out a scale. Can you see in this one, there it is, that your center line is going to be at minus 2, and your amplitude is 3. So when I draw in my axes, I might draw my axes so I have more space below the x-axis than above in this case, because I need to go down to minus 2. And I like to use a red pen and draw my center line with a dotted line. And remember, dotted lines in a graph, they're not part of your graph, but they help you draw it. So the center line is going to help us draw our graph, just like an axis of symmetry might help you with a parabola, or asymptotes might help you with a rational graph. This is just going to help us draw it, so we draw it in a dotted line. So that's the D part in DAB. The A part in the DAB, that's using your amplitude to find the maximum and the minimum. So since our center line's at minus 2 and our amplitude is 3, what will be the maximum? 1. What will be our minimum? Negative 5. So we go up 3 and down 3 from our center line. Next part in the DAB is the B value. The B value helps you figure out the period. Your period, in this case, we have a horizontal compression by a half. So normally your period is 2 pi. And if we do 2 pi divided by the B value, or apply that compression of a half, your new period is going to be pi. So you go somewhere along your x-axis and mark pi and divide it into 4 equal sections. So half of pi is pi over 2. Half of pi over 2 is pi over 4. And this is how I always do it. I figure out half first, I figure out half again, and then to figure out this third one, once you figure out that the smallest one is pi over 4, you can count by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4. And you can figure out what that third one is. Once you've done the DAB, you've got your center line, you've used your amplitude to find your maximum and your minimum. You've got your B value, which helped you figure out your period and divided that into 4 sections. Now we temporarily graph it. It's a sine graph. Where does sine start? Sine starts in the middle, going up. So we start in the middle. And it's going up, so it goes from middle to maximum, to middle, to minimum, to middle. So our maximum and minimums are important there to have labeled. Our 4 sections tell us where we need to go for our next point. And we're going to temporarily graph this. So we'll just graph it with a dotted line, because this isn't our final graph. But this graph is going to help us. And once we've temporarily graphed this, how do we apply our translation, the C part? It's going to be pi over 4 to the left. So luckily, our spacings are already pi over 4, right? So we can take each of the points we have and move them pi over 4 to the left. And once you've got those 5 new points, now we can draw our final graph. And although it's not super quick, it is faster and more accurate than if you'd taken those 5 points originally and had to do all the mental math with all 5 of them, with all 4 transformations. DAB-C is pretty easy to remember, I hope. We ready for a second example? All right. Example 2. y equals -2 cos pi x minus 0.25 plus 4. Oh, forgot a bracket. Nice, it's already in factored form, so that's good. So we're going to think about DAB-C. And before we draw our axes, we're going to think about the D and the A at the same time. Can you see that your center line is going to be at 4 and your amplitude is 2? Even though there's a negative out there, we still say that our amplitude is 2. Amplitude is always positive. So as far as setting this up, I don't need very much below the x-axis because my center line is at 4. No, period is also always positive. Center line is at 4. Our amplitude is 2, so what's our maximum value going to be? 6. What's our minimum value going to be? 2. What's our period in this case? Well, can you see that we have a horizontal compression by 1 over pi? Whew, that already sounds like not very nice numbers to work with. But if we use our formula for the period, our period is 2 pi divided by the b value. This actually simplifies quite nicely. It just becomes 2. So you mark 2 somewhere on your x-axis. And you might feel weird at first not having a pi on your x-axis, but that's okay. What's half of 2? 1. What's half of 1? 0.5. What's this one going to be? 1.5. Now we've got all the DAB done. So we need to temporarily graph it. It's a cos graph. A cos graph normally starts at a maximum. But since it's a negative cos graph, this one's going to start at a minimum. So we start at our minimum. Minimum to middle to maximum to middle to minimum. Temporarily draw it. And in the final graph, we need to move this one 0.25 to the right. Notice that 0.25 isn't marked on here. So we have to figure out where 0.25 is. That's going to be halfway between 0 and 0.5. And we need to move all of our points that much to the right. And there we have our graph. So now we are ready for example 1. For example 1, we've already sort of gone over part A. Predict how it's going to change. We know what's all going to change here. We're going to just work on part B, which is sketching the graph. So we're going to use this technique to sketch it. What's going to be hard in this situation is they are very specific here. They say they want the graph from -2 pi to 2 pi. That's going to make it harder. Most of the time on your final exam will say graph at least one period. And so then your life is pretty easy because we can do exactly what we've been doing all the way along. The fact that a domain is given to us from -2 pi to 2 pi will make this a little bit harder. But I'll show you how we can deal with that. So first of all, thinking about the DAB-C, you see that your center line is going to be at 2 and your amplitude is going to be 1/4. So when I go to draw my axes. And I put my axes right in the middle of my page because in the end I know I have to graph from negative 2 pi to 2 pi. So I need it sort of enough, the equal amount of space on the left side and the right side. Our center line is at 2. Our amplitude is 1/4. So we have to go up to 2.25 and down 1/4. We'll down to 1.75 to label our minimum and our maximum. What's our period going to be in this situation? 2 pi divided by the b value is 2 pi over 3. Now, before I label that, in the end, I want to graph this from negative 2 pi all the way to 2 pi. That's what the question has asked us for. Now, the period is 2 pi over 3. Where would 2 pi over 3 be on this scale? Right there. Perfect. 1/3 of the way to 2 pi? Does that make sense? If I divide this into 3 equal sections, that will be 2 pi over 3? Yeah. Because we've had a horizontal compression by a factor of 1/3. And so I can divide this side also equally. This will be negative 2 pi over 3. What would this one be if I labeled it? 4 pi over 3. And this would be negative 4 pi over 3. So this is what makes this question a little bit harder. By giving us the domain from negative 2 pi to 2 pi to graph it in, I set up my scale of where 2 pi and negative 2 pi are, and I had to figure out where 2 pi over 3 would be. This part here, 2 pi over 3. So what I did is if this is 2 pi, 2 pi divided by 3 is like taking 2 pi and dividing it into 3 equal sections. And so if this is 2 pi over 3, this is an equal space, would be another 2 pi over 3, and 2 pi over 3 plus 2 pi over 3 would get me to 4 pi over 3. And that's how I figured out that one was 4 pi over 3. Yes?
The more math you do, like the more not definite answer there is. So like just to make sure.
So once we've got our period, as far as finishing up the DAB part, you need to divide your period into 4 equal sections. So here's our period of 2 pi over 3. We need to cut that in half. What's half of 2 pi over 3? Half of pi over 3 would be? And this one, 1 pi over 6, 2 pi over 6, 3 pi over 6. 3 pi over 6 reduces to pi over 2. So once we've got the d value center line, the amplitude to get our max and min, our b value to do our period, which we have there divided into 4 equal sections, we can now temporarily draw our graph. So what does that look like? It's a cos graph. Where does cos start? At a maximum. So it goes maximum, center line, minimum, center line, maximum. And again, on your final exam, if they said graph at least one period, this would be enough. But unfortunately, this one says graph all the way from negative 2 pi to 2 pi. So what we're going to do is we're going to split this next period into 4 equal sections, and this period into 4 equal sections, and these ones into 4 equal sections, and 4 equal sections, and 4 equal sections. And we're going to continue our temporary graph. So maximum, back to center line, to minimum, to middle, to maximum, to center line, to minimum, to there and back. And we have to go on this side too. Middle, min, middle, max. Middle, min, middle, max, middle, min, middle, max. And our temporary graph all the way looks like that. Finally, we can do the part C, which means we have to shift this how much? Pi over 6 to the left. Nice thing is one ticky mark on our graph is pi over 6. So we have to move every single point pi over 6 to the left. So this one will move there, there. Here we go. Uh-oh. I'm a little bit,
You know the one you're going to give us on test?
got a little bit off there.
The one you're going to get in test, it's going to be this hard.
Hmm?
The one you get in test,
They won't be this hard.
amen.
This one's hard just because of the domain. And here's our final graph. Now I think what they wanted you to see, woo, so now we've did our temporary graph and finally moved it over. It's supposed to be symmetrical all the way through. We got a little bit of human error happening here. It looks a little bit wider here and a little bit narrow and skinnier there. If we had really good graph paper, that would have been better. So you'll find that on your exam, your final exam, on my tests and quizzes, I'm not going to ask you specific domains like this. I'm more often going to ask you just do one period. In that case, if you just had to do one period, this is the 5 points you would have done, and then you would have gone like this and added arrowheads on the end, and you would have been done. And life would have been nice and easy. But it's good to be able to work with different domains and think about it. So this shows you how you would do it over a specific domain, and you find your textbook questions do that a fair bit. Ask that.
Some domain like questions around list of that, but then it like the domain of negative pi 2, but then it says list the domain again. So you should just write that down again.
Yeah, I'll have to look at that question. If you can find one, I'll see what it means. Okay, so questions to do for practice, and what we're going to do for the last 5 minutes of class is 3, 8, 9, 10, and 11. And I want you to look at number 11 right now and tell me not why you would make a mistake, but why your neighbor is going to make a mistake on number 11. Why would the person next to you make a mistake on number 11?